All right, sorry about that interruption. So to recap, I looked at my coefficients on my x's. I've got a 1 and a 2. I looked at my coefficients on my y's, -1, +1. If I were to add a -1 and a +1 together, it would eliminate that variable. So that's exactly what I'm going to do. So x plus 2x is 3x. -y plus y, the y's have been eliminated, and 11 plus 19 is 30. Now solve the one-step equation. Divide both sides by 3 to find that x is 10. You'll notice that in the first system we solved for y, in the second system we solved for x. It will literally fluctuate. It will simply depend on where the eliminatable coefficients are as to if you're solving for x or y. So again, use caution when you're taking your solution and plugging it back into your equation of choice. Be sure that you plug it into the proper location in the equation in order to solve carefully for the other variable. I've chosen to use the top equation, x minus y equals 11, and you can see that I've substituted 10 in place of x, and now I'm going to solve the equation. I end up with a -y equals 1. If you will recall from our equations unit back in September, we are not allowed to leave a variable negative. So we need to go ahead then and divide by the understood -1, and that is going to yield y equals -1. As you solve a system, please be careful to write your solution as an ordered pair, remembering that an ordered pair is always x and then y. At this time, what I would like for you to do is to take and try number 5 on your own. Actually, scratch that. These are a little bit different. I want to be sure to show you each approach, so stay with me. Okay? So again, I'm still looking at coefficients, trying to find something to eliminate, hence the name elimination. -2 and -4 don't eliminate one another. A -9 and a -9 also don't necessarily eliminate one another unless I subtract the system. So when you are solving, you can add if that's what will eliminate, like it did for us in problems 1 and 3, or you can subtract the system if it's what will help you eliminate, like we're going to do here in problem number 5. When you are subtracting, please be careful that you use the sign each time. You can, instead of subtracting, distribute a -1 and change all of these signs, but I'm going to show you the subtraction way first. On the next problem, I will show you what it looks like in order to eliminate without subtracting. So -2x minus -4x. Remember that minus a negative becomes plus a positive, so it's really -2 plus 4 for 2x. -9 minus -9, so -9 plus 9, eliminates that variable. Excuse me. And then -25 minus -23 becomes -25 plus 23 for -2. You still end up with a one-step equation to solve. You're going to divide both sides by 2 and get that x equals -1. As you're taking your x and plugging it back in, again, remember, it does not matter which equation you choose to use. I'm going to use the first equation. Please take caution when you plug your solution in. Notice I was careful to show that this is a -1 going in place of x. Those sign errors can catch you. Please practice caution there. -2 times -1 is 2 minus 9y equals -25. Subtract 2 from both sides. -9y equals -27. Divide both sides by -9 and see that y equals 3. Remember, any solution to a system is written as an ordered pair. Okay? Again, comments or questions or concerns, then raise your hand and pause the video to ask me questions. Okay? Otherwise, I'm going to move on and show you number 7, and I'm going to do number 7 in the way of distributing a -1 and show you that method as well. All right, so here's this one. -6 and -6 could take each other out. A 6 and a 3 certainly do not. So instead of subtracting like I did in the previous system, I'm going to distribute a -1 through this equation to change every sign. So -1 times -6 becomes a +1. -1 times 3 becomes a -3, and -1 times -12 becomes a +12. This allows me to then add the system together so that -6 plus 6, the x's have canceled out. 6y plus -3y is 3y. 6 plus 12 is 18. One-step equation to solve. That's my favorite part of elimination. If you do step 1 right, step 2 is a one-step equation. That's pretty easy to do. Divide both sides by 3 so that y equals 6. Okay? From there, remember, you're taking your solution and plugging it into either of the two equations. Again, it does not matter which one. Take caution that you plug it in the proper variable location, okay? Plugging it in the wrong variable location would result in a wrong answer. You'll notice that that's why I actually take the time to write the entire equation out so that I don't misstep and accidentally put the y in for x or vice versa. -6x then plus 36 equals 6. Sorry, I'm realizing the lighting might be a little bit off for you there. Okay, minus 36 minus 36. So that -6x equals -30. Divide both sides by -6, and x is 5. Remember to write your solution as an ordered pair, using caution to be sure you put the x value first and then the y value. Okay? And those are your notes on solving a system with elimination for the first part of the problem. What I want you to do now is to take this sheet, and you'll notice that they've worked another example for you here, and I want you to practice by solving these 5 systems. Notice they've actually provided you with a place to write your ordered pairs nice and neatly. When you have these 5 finished, it's then that I want you to check these 5 answers before moving on to the next video segment of the lesson. Obviously, at any point, if you have questions on these 5, then please raise your hand or come to me and ask me your question. Great job and good luck.